day, dear subscriber, and you are welcome to Moses E tutorial. So far, so good, we've been able to touch indices. When I could remember in the last video, we talked about exponential function, because exponential function is just indices with an unknown power. So when an indices has an unknown power, so such indices is said to be an exponential function. Take for instance, when you have 2 to the power of unknown x, then this type of indices, we call it an exponential function because it is raised to the power of unknown. Unlike other indices that we have been treating, of course, you know, other indices we have been treating is 2 raised to power 2 or 10 raised to power 4 and thereabout. But in case of when you have indices, when you have an index that is raised to the power of unknown, and majorly you now see equal to in front, then this is an example of exponential function. Exponential function come to play majorly when we are asked to look for the value of unknown. When we are asked to look for the value of unknown in an indices. So when the power of an index is unknown and we have to calculate the value of the unknown, then we have exponential function. So this is an example of exponential function. So let's quickly take a brief example of exponential function before we go today. We have gotten some questions which are examples of exponential function. We have like 3, 4, 5 or 6 questions on the board which we should quickly provide solution to. So let's quickly solve these questions. Number 1. Solution. Number 1. 2 raised to power x is equal to 16. So what we do is, we are committed to ensuring that the base becomes the same. You want to make the base become the same. So if we are making the base to become the same, it means we are going to make this 16 to base 2. So how do we do that? It's very easy. We all know 16 to base 2. You have 8, 2, 4, 2, 2, 2, 1. 1, 2, 3, 4. So it's going to be 2 raised to the power of 4. Now, this now will now give us 2 raised to the power of x, then 2 raised to the power of 4. When you see now, we now have common base. So, you know, unlike indices, when you have common base, if it's multiplication, you pick 1, you add the powers. If it is division, you pick 1, you subtract the power. But unlike this equality sign, this makes it exponential function. So we now have equality sign in between. All we just do is we use the base to cancel each other. So if the base cancel each other, then we now have x to equal to 4. That is that about number 1. So you can see how easy exponential function is. Now number 2, we have to simplify 3 raised to the power 2x equal to 27. The same way as we solve this, we are going to solve this. Let's make the same, let's change them to the same base, which is 3. So this is 3 raised to the power of 2x will give us, of course, 27. Now to go about it, 3 in 27, 9. 3 in 3, 3 in 9, 3. And 3 in 3, 1. So that will be 3 raised to the power of 3. Then 3 can cancel 3. So if 3 cancel 3, now have 2x will give you 3. Of course, when you have this type of equation, you know 2 divide 2 divide 2. 2 cancel this, then x gives us 3 over 2, which is then as 1 over 2. That is the solution to number 2. I hope it is clear. Very good. Now, let's take number 3. Number 3, x is raised to the power of 1 over 3, which is equal to what? 3. Now when you see, this is a bit somehow. This is a bit somehow tough, but it's not tough. Now when you have a question like this in mathematics, to get x is very, very easy. When you have cube root of x equal to 3, so the next thing in mathematics is that you find the cube of both sides. So take the cube of both sides. So we want to take the cube, so that will be the cube root of what? X raised to the power of 3 and the cube root the cube of 3. Sorry. The cube of 3 and the cube of this. So you remember in our indices, we return it to this now. So you now have x raised to power 1 over 3 times 3 to give you 3 raised to power 3. We are returning this back using the law of indices back. So that is why we bring it, then you have 3. So that's that. Of course, you know this will multiply this we cancel this. So that's x now. We give you 3 cube, which is 27. I hope you understand. Now, let me come back again. When you have something like this, change it, use the law of indices, bring it to this form. So that's cube root of x equal to 3. Then to what to 3? Then to get x is for you to take the cube of both sides. So take the cube of this side, left hand side, take the cube of the right hand side. So when you take the cube of this now, change this to law of fractional index. Yes, law of fractional index. So cube root of x now become x raised to power 1 over 3 as we did here. Then the 3 is still there. We multiply with the 3. So the 3 cancel the 3, then you have only x. So you have 3 cube and your answer is 27. Thank you. Alright, let's quickly move to number 4. Number 4 says evaluate. Number 4 says we should evaluate 4 raised to power x equal to 32. So we want to make the base. Don't forget, the first thing is for you to make the base equal. So if the base are not equal, there is nothing you can do. So to make the base equal, of course, this will be 2 over 2 for x equal to 32. Do you remember our procedure? 2 in 32, 16. 2 in 16, 8. 2 in 2, 4. 2 in 4, 2. 2 in 2, 1. 1, 2, 3, 4, 5. So that's 2 raised to the power of 5. So 2 can cancel 2. Then your 2x now will equal to 5. Then your s, of course, you divide both sides by 2. So your 2x divided by 2 will give you 5. Divided by 2, it should give you 2 odd number, sorry. It should give you 2 odd number 1 over 2. That's kind about number 4. Now let's solve number 5 and number 6. Number 5. For number 5, we have 27 raised to the power of x plus 2 equal to 9 raised to the power of 2x. We are committed to using the same approach. Make the base the same. Make the base the same. We've done for 27 in the question. We've done for 27, number 2. Look at it, 27. So that's 3 raised to 27 is 3 raised to power 3. Don't forget this, you put it in the bracket. 9 is 3 raised to power 2 into 2x. So this will cancel this. Do you remember? Then you have 3 raised to power x plus 2. 2 into 2x. So when you expand the bracket, 3 times x, you have 6x. 3 times this, you have plus 2. We said 3, we cancel 3. So when 3 cancel 3, we are left with 3 into x plus 2 equal to 2 into 2x. Right? Yeah. So 3 times 2 will give you 3x. Oh, sorry, 3 times x will give you 3x. Then 3 times 2 will give you 6. 2 times 2 will give you 4x. Then the next thing is to collect the like terms. So take 3 to the other side. So 6 gives you 4x minus 3x. So 6 will give you x. So it's written as x equal to 6. Now, the last one, number 6. We have to evaluate 8x, this is by x minus 3 equal to 32 raised to the power of x plus 2 over 4 raised to the power minus x. Now, I've told you that we should first make sure that they all have the same base. So 8 to base 2 will give you 2 raised to the power 3 into x minus 3 equal to 32 to base 2. I think it's 2 raised to the power 5. We've done it the other time. That's 2 raised to the power of 5. Yeah, number 4. Where is number 4? Look at it. 2 raised to the power 5. So 32 is 2 raised to the power 5 into x plus 2 over 2 raised to the power of 2 into minus x. This is division, common base. So you have 2 raised to the power 3 into x minus 3 equal to, common base with big one, we had the remaining 5 into x plus 2 minus, so we said common base, we pick one, then because of the division we are subtracting, minus 2 into minus x. So you have 2 raised to the power of 3 into x minus 3 equals to 2 into 5 x plus 2 plus 2x. Minus times minus plus then 2x. So this can cancel this. Then you now have 3 into x minus 3 equal to 5 into x plus 2 plus 2x. Let's expand the bracket. You have 3x minus 9 equal to 10. Equal to 5x plus 10 plus 2x. So let's collect the like terms. You have 3x, bring this minus 5x, bring this minus 2x equal to 10 plus 9. So subtract this minus this, you have minus 2x minus 2x, you have minus 4x, give you 19. So of course we know grab beside minus 4, minus 4. So x now will be minus, that will be minus 19 over 4, which is 4 odd number. 4 times 4, that's 16, minus 19, that's 3 over 4. So solving these 6 questions, I think we've done exponential function to a particular extent. I think the only thing we need to do now is those questions that used to end in simultaneous equation, those questions that used to end in quadratic equation. And by the grace of God, in our next video, we will treat such questions. And never forget, before we go, that in life, you cannot do away with the God factor. Because your whole in all depends on God. Whatever you become, God must be fully involved. Thank you very much.